Hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode daily problem, minimum cost to make at least one valid path in a grid. So this is a hard level question. And so now let's look their problem statement, and after that we have to look their example test cases and their sample code. And so in this problem, we have to given a grid m cross n, and each cell in the grid contains a sign that points the next cell to visit, and the direction we have to given here. One, we have to given grid of ij, two grid of ij plus 1, and so on. We have to given 1 2 3 and 4 directions, and after that we have to return the minimum cost to make the grid have at least one valid path. So now let's look their problem statement. So in this problem we have to given one, we have their right. If one, the right is grid of I j plus 1, and same thing for uh, 2. This 2 is our grid of I j minus 1, and this is our left side. And third, we have given grid of I plus 1 and j. This is our down, and last is our grid of I minus 1 j, and this is our uh, up upwards direction. So these four conditions we have to given here, and after this you need to start your point. We have to start from top left corner, top left corner, and grid of this is our grid of 0 0. So this is our initial position, and we have to aim to reach bottom left corner, bottom right corner, sorry, bottom right corner. So right corner condition is grid of m minus 1 n minus 1. So this is our condition for starting to last position. Like if this is our grid, so our initial position we have to start from this one to end with this one. Okay, so now each sign of the grid we have to given each sign, like this direction, this direction, this direction, and this one. So these are our signs, and we have to given the signs. And so you can modify the sign. Our problem statement is we have to modify the signs and in the grid to point in any direction. Like whenever we have to take care, like when the sign is above direction, then we have if the condition is like this sign is this position, like to downwards position, then we have to change this. So these are our conditions for changing the sign, and you can modify the sign in the grid to the point in any directions, but each modification cost is equal to 1. So whenever we have to modify our sign, let's suppose we have three modification, like one modification of this one is this, and this modification is this, so cost is equal to 2, and so on. Like whenever we have to change their actual sign, so the cost is increase. And so your goal is to find the minimum cost required to make a valid path from we have we have there the we have to find minimum cost required. to make a valid path from 0 comma 0 to m minus 1 comma n minus 1. So this is our conditions we have to given. And so the goal is first we have to start at grid 0 comma 0 and find a path to grid m minus 1 to n minus 1, and we have to minimizing the cost of modifying signs. And the last one is the valid path does not need to be the shortest. So we have to given these three uh, conditions we have to take care, and we have to find their minimum cost required valid path. So now let's look their example test case for understanding how actually this problem statement work. And so this is our example one. So in this example we have given, this is our initial condition, this is our init position, and now you initially follow the grid direction, and we have to take care how we can reach this position. Okay, so now firstly initially we have start from 0 comma 0, then we have to move right side, this right side we have to move, this is move condition, we have to move right side. So the condition is what we have to get, start from 0 comma 0 to 0 comma 1, 0 comma 2, and third is 0 comma 3. And to now to move down you can modify the arrow at 0 comma 3. This arrow we can modify because this sign is their right position, but we have to track whole grid. So there is no any direction to move another level, so that's why we have to change this one to this one, and our cost is equal to 1, and this sign is changed to this one. Okay, this one. So after change, so our path is 1, cost is 1, and our path is to move down. So 1 comma 3 you need to modify, you must modify the arrow at 0 comma 3 to point down 3, and the cost is equal to 1. So here we have to change the here we have to change the direction. And now so this is our first one, and now here we have to get from 1 comma 3 we have to left move left. How we achieve here, 1 comma 2, 1 comma 1, and 1 comma 0. So these are our path from these are our path, like we have to move this direction now because of sign. So now we have to reach at this position. Now in this time we have to reach this position, so we have to change this direction because we have to track these two grids more. So we have to change the direction with downwards. So after changing here to move down to 2 comma 0, you must you must modify arrow at 1 comma 0, and this is our 1 comma 0, and this is our 0 comma 0, and this is our 2 comma 0, and this is our 3 comma 0. So we have to change 1 comma 0 now. 1 comma 0 to point down, down, point down, and which position? To 3. We have to change to track with this position. Okay, so now we have to change 3, so cost is equal to 1, and cost we have to change. After cost we have, lastly we have to calculate all cost. Okay, so now what we have to get here, from we have to 2 comma 0, 2 comma 0, move right, move right, and move right to 2 comma 1, 2 comma 2, and 2 comma 3. So these are our following paths. And now this is our 2 comma 0, 2 comma 1, 2 comma 2, 2 comma 3, and same thing for here. And now at this point we have to reach this position, but one clue is here, we cannot track with this level, so that's why we have to change this sign to downwards. So now after this, to move down, to move down, like 3 comma 3, to move down for 3 comma 3, and the arrow we have to move, we have to modify the arrow of which position, 2 comma 3 position. This is 2 comma 3, arrow of the 2 comma 3 we have to modify, and we have to point down. This is our point down, and the arrow we have to change. This is 3 position, and so now the cost is equal to 1. And after this, when we have to change this position, so now what we have to get, this condition we have to satisfy this one, and after this we have to move down, then we have to track this one, and we have to again move down, we have to track this one, and again we have to move down, and we have to again track them. So what we have to get here, this we have to change here one thing, and again we have to down here, then we have to change again here, then we have to down, and again we have to change here, but we have to down here. So now how many changes we have to done here? 1, 2, and 3. So now same thing, 1, 2, and here we have to 3. So total cost is equal to 3. So I hope you understand the how we can achieve to find their positions and how and their values. So our goal is to reach in this position. Okay, so now we have to track with their table form. So now let's look at this. So first, 1 second, like we have to track with normal table form. Okay, so here we have to track with their steps. These are our steps, and now the current cell, we have to current cell, and next we have their direction. These are our direction, and the next cell, there is next cell, and after that we have their cost, and here we have to modification, it is true or not, yes or no, you can say. And so now steps are, we have their first step, we have init position. What is our init position? 0 comma 0, and the direction is our right side. Okay, the direction is our right side, r1, and the next cell is 0 comma 1, 0 comma 1, and the cost is 0 because we have not changed anything, and the modification is nothing. And same thing for step 2. Here we have 0 comma 1, r r1, okay, r1, and this is our 0 comma 2, cost 0, and we have nothing to modify. And third thing, we have 0 comma 2, right 1, 0 comma 3, next cell, and 0 and n, because we have not changed anything here. And now 4, we have 0 comma 3, r, sorry, because in this time we have to down our value. Okay, so down our value, so which grid we have to change? We have this one, 4 comma 4 grid we have to given here. So here we have to change, this is our third case. So we have to down third one, and so 1 comma 3 and 1, cost is 1 because we have to change here, and we have to modify, yes. And now fifth condition, fifth step, here we have 1 comma 3, and direction is L2 because we have to track with uh, left side. And so here 1 comma 2, and here cost is 0, and now here no modification. Sixth is 1 comma 2, L2, 1 comma 1, nothing to modify, nothing. And same thing for here, 1 1, L2, and same thing for 1 0 and 0, no. And yes, now up, when here we have to modify our point. So here eighth step, 1 comma 0 is we have to modify down 3, because we have to move third cell. So d3, and here the new condition is 2 comma 0 because we have to start with their second cell. So here we have to change their cost 1, and yes, we have to modify. So same thing for all these position, and we have to get cost is equal to 3. So now let's look there one more example for, yeah, this one. So this one, you can follow the initial sign, we have to follow this sign. So this is our init position. Initially we have to here, and we have to move forward, then we have to down here, again move forward, down here, and again move forward. So now without any changes we have to reach our goal. Okay, 0 comma 0 to m minus 1 comma n minus 1 position. So I hope you so that's why the cost is 0, because you can follow the path from 0 to 0 to 2 to 2. So I hope you understand the logic of and their example test cases. And so now let's look their constraint one more time. So here we have to given constraint m is equal to grid dot length and n is equal to grid I dot length, and we have to given the dimensions of n and n with less than is equal to 100, and every cell and we have to given the dimensions are small, uh, and we have to making the uh, feasible solution for this problem, and 1 less than is equal to grade ij less than is equal to 4. The every cell we have to contain one of four positions, possible positions, sorry, one of four possible directions we have to given here. And so now let's look their coding implementation part. So one second here. So now first we have here n comma n we have to define here. And now this cost is 2D vector to initialize to store the minimum cost. This is store the minimum cost from each cell with initial all values set with the large values is 1 e की power 9. And same thing we have to initialize with their cost 0 comma 0 to initial position, and this is our set position. We have to set their values, and after this now we have to create a min heap. This is our min heap for priority queue. This is our STL in C++. So we have to create a min heap, and after uh, min heap of priority queue to use the process cells with their lowest cost first, and the queue store first. We have to store cost, and we have to store row comma column. And so this is our priority queue for storing all values. And now here we have pq dot push. This pq dot push to starting cell of 0 comma 0, and their cost is 0. Here 0 comma 0 and 0. So this is our possible values to push. And now the direction is the array of direction represent their grid values, like up direction, right direction, down direction, and left direction. So these are our directions. And now this loop continues while there are cells is processed. So we have to running this loop, this while loop. And so this is simple of we have to already declare with their second dot first value, second dot second value. And now this 4 time loop is the process loop iterate through the 4 possible directions to move from the current cell. The current cell is our first comma second, this one. Okay, so this is our a possible direction to move current cell. This is our current cell, and this row and column represent the neighboring cell of the current direction. And after this we have to work with their cases. These are our case, like the row greater than is equal to 0, and row less than n, and column greater than 0 and column less than n. It ensure the neighboring cell row comma column within grid boundaries. These are our boundary condition. And so here we have to check this one. We have to check with check less than cost row column, and it is a current cost to check is less than the recorded cost. And for the next cell and row comma column, update the cost and push into queue. And here we have same all these conditions, like this is for our first, and this is for our second, this is for our third, and this is for our fourth. Like we have also said that here, like here 1 2 3 and 4. So same thing we have to implement on our code. So this is our 1, 2, 3 and 4. So I hope you understand these logics. These are some simple logics for uh, to check with initial position to all other grid position. So now this is our else if condition. This is the next. This is to find the next cell does not match the direction direction, and we have to modify direction at a cost at a cost at a cost of +1, and we have to update and push into our queue. And so after that we have to return their minimum cost, these two bottom right cell, and we have to return this. And so now that we have to look their time complexity. So that so the time complexity is so the time complexity of this code is we have to initialize O of n into m, and after initialize this is our cost, and that we have to process all these things with Dijkstra algorithm. And this Dijkstra algorithm, we have to process each cell once. We have to process each cell, and after each cell, once we have to iterate through 4 neighbors. We have to iterate 4 neighbors, and the total time complexity of this one is like we have to push, we have to pop, and this one is taking log of n into m time, and the total time complexity of this code is O of n into m into log of n into m. So this is our time complexity of this code is. And so the space complexity of this code is O of n into m. We have to create a cost vector, a vector of vector, 2D vector we have to create. And so O of n into m from the priority queue to storing the cells. So the total time complexity of this code is so the total space complexity of this code is O of n into m. So I hope you understand the logic of this code and their implementation part. So thank you everyone. Thank you so much.